In this video, I will be showing you a step-by-step guide on how to construct a swinging pendulum. I have included tips and tricks that will help you along the way. If you have any questions, I suggest meeting with your class teacher during lunches or asking an experienced junior or senior for help with the project. Good luck! Before you can construct the frame for your pendulum, you first need to figure out what your length in width and height will be, and I'm going to show you how to arrive at your desired length. What you see here is a diagram of my top piece of wood for my pendulum frame. The first step to determining the length of the wood is to choose how many weights you would like to have on your pendulum. I chose to have 10, which is the minimum amount of weights allowed. The more weights you have, the more satisfying and apparent your pendulum swings will be. But it is also harder to tune, so you can make that decision. The next step in the process is determining how far apart each string will be from the next. Each weight needs to have an equal amount of space on each side of it. As you can see, you need to leave room on each end of the top slat for your dowels to be. I left a 1.5 inch margin on each side for the dowels. I then measured the space in between the dowels, which for me was 15 inches. By figuring this out on paper first, I was able to deduct that the length of my top slat of wood on my pendulum frame would be 18 inches, minus the 1.5 inches on either side of the strip of wood which I left for the dowels, which gave me 15 inches for my weights and strings to be. Next, I divided 15 by 12 so that each string would have 1.25 inches in between each set of strings. At first, I assumed that I would divide the space by the amount of weights that I wanted, 10, but I realized that by doing that, you aren't leaving room for the strings on each end of the wooden slat. By dividing by 2 more than the amount of weights that you have, you will ensure that there is also 1.25 inches on each end of the last set of strings. Remember that these are my specific measurements, and all the measurements will be different if you choose to have less or more weights on your pendulum. The next step in the process is to divide your wooden slat by half and then divide the top half in half again. Connect the 10 points that you made down in a line through your horizontal lines. Make sure that these are straight. I suggest making the points on either end of the wooden slat in order to make sure that they are perfectly vertical. Next, you are going to draw lines that are around 3/4 of an inch away from your already drawn line. For example, here is my first line where my first hole is going to be, and right next to it I drew a line 3/4 of an inch away, which marks where my second hole will be, in which the other end of the pendulum string will go. The two ends of the string do not have to be this specific distance away from each other, but I do suggest not making the distance any closer, because the closer the distance between the two ends become, the more the center of the string where the weight is hanging will begin to twist, which will make your tuning of the pendulum inaccurate. I have color-coded a key below the diagram. The dots represent the holes that you will drill for your strings to be threaded through. Look at the correlating color key below to see which string goes in which hole. In order to find the length of each string of the pendulum, you will need to use the equation T equals 0.2 square root of L. You then need to rearrange this equation so that it is equal to square root of L, because we are trying to find the length of the string. You will do that by dividing both sides of the equation by 0.2 to get square root of L by itself. Your equation should now look like this. Square root of L is equal to T over 0.2. It is now important to get rid of the square root on the L, and to do that we are going to square both sides of the equation. Your equation should now be L is equal to T squared over 0.04. You now need to decide how long you would like it to take for all your pendulum strings to complete the right amount of oscillations. I chose for my pendulum strings to complete their oscillations in 40 seconds. For each string, you will increase the number of oscillations that it completes by 1 each time. So my first string will complete 35 oscillations in 40 seconds, but my second string will have 36 oscillations in 40 seconds. And my third string will have 37 oscillations in 40 seconds, and so on and so forth. And I'm now going to show you how to arrive at the final length of a string. The t in the equation represents the amount of time it takes for one oscillation. You are going to divide the amount of time that you've chosen, which for me was 40 seconds, by your number of oscillations, which for me was 35 oscillations, which is equal to 1.14. Your equation is now L is equal to 1.14 squared divided by 0.04. When you solve this equation, you get the answer L is equal to 32.653 centimeters. I rounded this to 32.7 centimeters because you can't measure beyond a millimeter on a ruler. Now use the equation again that we previously found to plug in your time and number of oscillations, remembering to increase the amount of oscillations by 1 each time. So, your next equation, if you're doing the same amount of time as me, would be 40 divided by 36 is equal to whatever that answer is. So your equation would be L is equal to your answer squared over 0.04. Now that you have completed measuring the length for your strings, make sure that when building the frame, you are compensating for the length of the longest string in height. I suggest taking the length of your longest string and adding a few inches to that for the height of your pendulum frame. I have compiled a list for the materials that you will need in order to build your pendulum frame. You need 2 pieces of wood that are the same length for the top and bottom of your pendulum. You will need 4 dowels, 2 for each side of your frame. You don't have to use dowels, but I found that those were the easiest to use. I also needed 4 pieces of wood to stabilize the project, but this was only because my structure was not strong enough to support my heavy weight, so if you don't want to run into this problem, I suggest using very light weights. You will also need various power tools and also nails, screws, and also some glue. Here is what my pendulum frame looked like after completion. It consisted of 2 pieces of wood on the top and the bottom that were both 18 inches long, and also 4 wooden dowels. Your frame does not have to look like this one. You can make it any way you would like as long as it is functional. Here is a list of the supplies that you'll need for the assembly of the pendulum. You will need a minimum of 10 weights with loops at the top. You will also need a minimum of 10 eye hooks. You will also need string. I do suggest using a thin string and not a thick one in order to create less friction within the holes that you drill, but I do not suggest using fishing wire because it is hard to tie and is generally stiff. You will need a drill with a suggested drill bit of 1/16 of an inch. If you use any bigger of a drill bit, your string could move around in the hole, which would change the pivot point, and that would be a problem for your period of oscillation. You will need a needle to thread your strings through the holes that you drill, scissors to cut your measuring strip, which I'll show you how to do, paper as well as a centimeters ruler. Inches would work too, but centimeters is much easier. When you have completed your frame, draw out the construction lines, which I previously showed you how to do, and then begin drilling your holes, being extra careful to put them in the right spots. Here, I'm drilling the holes where my eye screws will go into. It is hard to just put the eye screw on the place where it is supposed to go and begin to twist it in. I believe that the easiest way to do it is to drill a hole that is slightly smaller than the width of the base of the eye screw and then put in the eye screw. Make sure to hold your drill as straight as you possibly can because you do not want your eye screw going into the wood at an angle. Here I'm drilling the holes where my strings that are going to be connected to the eye screw will go. Please remember to use a very small drill bit when drilling the holes for your strings. If you use a big drill bit, the strings could shift around in the hole that you've created, which would change the pivot point of your oscillation, which would greatly affect the period of oscillation, and it would not stay consistent. I suggest using a 1/16 drill bit, no matter what string you are using. In order to measure the strings for your pendulum, refer back to your page of equations. Measure the general length of the first string with a centimeters ruler, and then double that length, because this is how your string will hang. And then add around 6 inches to the length for wrapping around the eye hook. After threading your string through one hole and tying it around the eye hook using a needle, thread the second string through the second hole, referring back to the key if you are confused about which hole this string goes into, Tie a double knot and let it sit on the hole. It should not go through. Here I'm threading the second end of the string through the hole that is 3/4 of an inch away from my string that is connected to the eye hook. When first making my pendulum, I made the mistake of threading 2 strings in one hole. I assumed that this would be fine, and I thought that it would be more functional than having to drill for more than 2 holes. But I learned that when you have 2 strings in one hole, it creates friction at the pivot point, which can greatly change the period of oscillation, and it will not be consistent because the strings will be rubbing against each other as they swing. To compensate for this issue, I re-drilled extra holes, which is how I showed you how to do this project, and it turned out successful. Here is what the top of your pendulum should look like. Now, in order to tune each string more precisely, you must use a centimeter's ruler to measure the length of each string from the pivot point to the center of your weight. I originally tried using a centimeter's ruler, but there was extra space on the end of the ruler that was not part of a centimeter, which made it complicated to measure the length of my string. Instead, I made a strip of paper that was the exact length of my longest string, and then marked the lengths of my shorter strings down the strip of paper using a centimeter's ruler to make those markings precise. Here's what my strip of paper / new ruler looked like after I had put all of my pendulum lengths onto it, and then I cut it out. The last step of making a functional pendulum is the most tedious and time-consuming, and I'm going to show you just how to do it. If the string is too short, turn the eye screw to the left, lengthening the string. If the string is too long, turn the eye screw to the right, shortening the string. If you are measuring the 4th string, fold your paper strip to the 4th line that you made. Remember that the length that you are measuring is measured from the center of mass to the pivot point, which on this pendulum is measured in between the 2 ends of the string, so hold your strip up to the wood in between. So step 1 to perfectly tuning your pendulum you already did, which was making sure that the length of each string was as correct as you could make it. And step 2 is timing the number of oscillations in 40 seconds. So for this string, I wanted it to do 35 oscillations in 40 seconds. So I counted those oscillations. It ended up making 35 oscillations in 40 seconds, which is exactly what I wanted, so we're all good for that one. Step 3 is to measure the string right next to it. Repeat the exact same process, except that this time your number of oscillations is going to be 1 more than the time before. Which brings us to step 4. Now that you've measured these 2 strings individually and you know that they are both correct, time them together, releasing them at the exact same time. You want them to come together after 40 seconds. As you can see, these did not come together at 40 seconds. They came together at around 42 seconds, so they need to be adjusted. I'm going to just tighten it a little bit because since it came together too late, the string needs to be shorter. I'm next going to time the same 2 strings together at the same time to see if my adjustments made a positive difference. Continue this process of adjusting and retiming until you get it perfect. Now that I know that my 2nd string is correct, I'm going to individually time the 3rd string until I get that one correct individually. As you can see, it did 37 oscillations in 38 seconds instead of 40 seconds, so I'm going to readjust that. And now that I got that 3rd string readjusted perfectly, I timed the 2nd and the 3rd string together and readjusted that until those 2 were also perfect. Now I know that I have 3 perfectly timed strings. Continue this process for all the other strings until you've done all of them, and then test them all together. Even though my strings were perfect at the time, they can come undone a little bit, or my reflexes weren't fast enough, so I stopped the stopwatch too soon or too slow, but my pattern was not perfect in the end, so you just need to look at which balls are lagging or which balls are going too fast and then adjust those accordingly. Do not go back and fix all of them because that will actually make your pendulum worse, which I learned from. So as you can see right here, this one is going too slow and this one is going too fast. So you're going to want to make those adjustments accordingly. This is what your final completed correct pendulum should look like. That is the end of this instructional video. I hope that it was helpful and that your pendulum was successful, but if not, please remember to ask a teacher for help or a peer tutor.